Welcome to this late-night explainer from the Midnight Observatory. We are transmitting on a low frequency tonight, cutting through the static to look at a phenomenon that simply refuses to fade into history, the flat Earth theory. But we aren't here to mock or belittle. We are here to uncover the profound mechanics of how we know what we know, to explore the boundaries of human belief, and to reveal the true hero of our collective persistence. Settle in and let's get grounded.
I want you to consider something for a moment. How much would you be willing to bet on the fundamental shape of the ground beneath your feet? In January of 1870, a man named John Hampden laid 500 pounds on the table. That was an absolute fortune back then. His wager was simple yet audacious. He bet that no scientist alive could actually prove the Earth was a globe by demonstrating physical curvature on a body of water.
Part 1. The Bedford Level Wager.
The 19th century was already vibrating with complex scientific proofs. Over in Paris, Léon Foucault had recently suspended his massive, striking pendulum, physically demonstrating the rotation of the Earth. But the man who stepped up to take Hampden's bet didn't rely on complex physics or grand mathematics. Alfred Russel Wallace, the very same mind who independently conceived the theory of evolution alongside Darwin, agreed to a starkly simple visual test. He chose a dead-straight, 6-mile stretch of the old Bedford River in England. No tricks. Just human eyes over a quiet stretch of water.
The setup was elegantly unforgiving. They placed 3 markers at the exact same height above the water, spread evenly over those 6 miles. Now here is the critical part. The predictions had to be locked in beforehand. On a globe, the water curves downward and away, meaning that the middle marker must appear higher through a telescope. But on a flat plane, all 3 markers would perfectly align in a straight row. 2 distinct models, 2 entirely incompatible predictions.
Wallace peered through his telescope, carefully adjusting for atmospheric refraction, and there it was. The middle marker sat distinctly higher, a definitive, measurable curve. But here's where the story takes a sobering turn. Hampden refused to see it. He outright rejected the results, accused Wallace of cheating, and spent years waging a bitter harassment campaign. Wallace won the money, but Hampden's denial gives us a fascinating, cautionary look at what happens when undeniable physical evidence collides with deeply entrenched belief.
Part 2. Ancient Proofs of the Globe.
So why was the scientific community already so incredibly certain that Wallace would win that bet? To answer that, we have to turn the clock back way before modern space agencies. Around 240 BC, an ancient Greek geographer named Eratosthenes accomplished something staggering. He calculated the Earth's circumference to be roughly 40,000 kilometers. He didn't use advanced technology. He simply observed the different angles of shadows cast by the sun in 2 Egyptian cities at local noon. A 7.2-degree difference in shadows, a little basic geometry, and he had successfully measured the globe.
Because of that foundational geometry, we can mathematically predict the horizon. The standard formula yields a drop of about 8 inches per mile squared. It is a quiet, observable fact that mariners have bet their lives on for centuries. When a ship sails away, the hull disappears before the mast. It is not an optical illusion. It is a literal mountain of curved water physically obstructing the view.
Part 3. The modern flat Earth resurgence.
Now, let's open up the global mailbag. We've got a message here from Silas, listening from a rainy porch up in Juneau. Silas writes, if the science has been settled for thousands of years, why are so many people suddenly claiming gravity is a lie and that an ice wall surrounds us? It is a vital question, Silas. We cannot just dismiss this as simple ignorance. This internet-fueled resurgence acts as a psychological umbrella for a much deeper societal distrust. It is a strict rejection of mainstream authority, fueled by a profound feeling that the true nature of reality, from NASA to the fundamental forces of physics, is being intentionally hidden from the everyday person.
To support this worldview, proponents look for everyday observations that seem to defy the mechanics of a spinning globe. They ask, if the Earth is truly rotating at hundreds of miles an hour, why can't a hot air balloon just ascend, hover in place, and wait for its destination to violently spin right underneath it? It sounds intuitive at first glance, but it completely ignores the fundamental reality that our atmosphere, the very air providing lift to the balloon, is being carried right along with the Earth's rotation.
They also challenge forces like the Coriolis effect. We've all heard the pop culture myth that toilets drain in opposite directions depending on your hemisphere. Flat earthers rightly point out that this is entirely false. The shape of the bowl actually dictates the flush. But they use that broken myth to dismiss the Earth's rotation entirely.
They ignore the fact that the actual Coriolis effect is a massive planetary force, one that dictates the rotation of hurricanes and forces long-range artillery gunners to mathematically account for the Earth spinning beneath their shells.
Part 4. Testing Flat Earth Models.
So, how do we break the deadlock? How do we impartially test these claims without just arguing endlessly in circles? We rely on the true hero of this story, and the twist is the hero isn't a person at all. It is a process, the scientific method. It is humanity's most rigorous filter for reality, designed to protect us from our own biases. It demands that you observe, form a hypothesis, and crucially, make a strict prediction before you ever collect a single piece of data.
Let's go back to the global mailbag for a moment. Elena from a high-rise in Tokyo asks, how can we test the flat Earth model ourselves without trusting third-party space agencies? Elena, we can do it today by simply looking up. The modern flat Earth model claims the sun is a small local light circling just a few thousand miles above a flat disk. If true, the laws of physics demand that its angular size, how big it appears to our eyes, must shrink drastically as it moves further away toward sunset. The globe model, however, places the sun 93 million miles away. At that immense distance, the sun's apparent size must stay completely constant all day long.
The predictions are locked in. Now, we take the data. When we carefully measure the sun from noon to sunset using a fixed focal length telescope, the results are completely undeniable. The change in the sun's angular size is exactly 0. It is a flat line. This measurement perfectly matches the globe prediction and completely, physically falsifies the local sun hypothesis. The sun simply does not shrink as it sets.
Part 5. Science versus conspiracy thinking.
What happens next separates the skeptics from the scientists. When the physical data definitively breaks a prediction, how do believers react? In the realm of conspiracy thinking, new, untestable excuses are invented on the spot. They might claim that mysterious perspective laws or atmospheric lensing is magically hiding the sun's shrinkage. This is a logical fallacy known as post hoc rationalization. It is frantically adding patches to a sinking ship just to ensure it survives one more day rather than admitting the hull is breached. The scientific method is built on the exact opposite foundation. True trustworthiness as an observer of this universe comes from the profound willingness to be proven wrong. When a prediction fails in science, you do not patch a broken theory. You accept the failure, you study the wreckage, and you build a stronger, truer model that actually reflects physical reality.
We are closing down the observatory for the night, but I will leave you with this final thought. The scientific method is ultimately a wager. It requires you to place your bets before you ever see the cards. So the next time you encounter a compelling, paradigm-shifting theory online, ask yourself, does this idea truly have skin in the game? Can it make a strict prediction? And does it have the courage to accept reality when the data finally comes in? Thank you for joining me on this explainer. Keep questioning, stay grounded, and always let the data lead the way.